Hi guys, welcome to my mathematics tutorial, and my name is Peter C. Douglas Jr., your mathematics tutor and an instructor of mathematics at the University of Liberia. In my today's lecture, I'll be doing additional problems on a variable separable. In the previous lectures, we did like 6 problems. So we want to look at the 7th problem on a variable separable. So we told you initially that when you have a differential equation wherein you can easily separate the variables in x from the variables in y. That is to say, you put all of the expressions with the variables in x on one side of the equation and the ones in y on the other side of the equation. Then you can apply variable separable method to find a general solution. So this is what we want to do. So let's get started. So now we have question number 7. And this is the problem. We have y minus x dy by dx times x all equals to y. So we can simplify. We have x times y is xy minus x times this is like x squared dy by dx all equals to y. So we can quickly do that. You have now what I can do, I can send this term across, right? Or I can send this term across, whatever way I can do it. So let me send this one across, since this one has negative attached to it. So I have x, y, I bring this one across, it will be minus y. Because I'm seeing y here and y, so I can factor out y. And then equals, so if I send this one across, I will have x squared dy by dx. Now, if I factor out y here, I will have y times x minus 1 equals x squared dy by dx. Now, I can cross multiply. So I will have x squared dy equals, now this time this is like y x minus 1 dx. So because this is the variable of integration, which is x, all of the expression here must be in x. So this is not in x, so I divide both sides by y. Likewise with this, the variable of integration here is y, so I must divide both sides by x squared. So x squared will cancel this one, and then this side y will cancel y. You have dy now by y equals to x minus 1 all over x squared times dx. So we can now integrate both sides now since the variable have been separated. So the integral of dy all over ln of y is just all over y, it just equals to ln of y. And then for this one, we can separate them, x over x, right? X over x, and then minus the integral of 1 over x dx. So you have the ln of y equals, now x over x is just 1, minus the integral of 1 over x is just ln of x. So this is just equal to x. The integral of dx is just equal to x. So I'll just put x. And then we attach plus some arbitrary constant c. So if we let, we can group 1 and 2. We can group them. So we got ln of y plus ln of x equals to x plus c. So we group these two. ln of a plus ln of b is equal to ln of a times b. So this will just be ln of a or x times y, or equals to x plus c. Now remember, we want to solve for x, we want to solve for y, right? So we could further simplify this problem by rewriting it as e raised to the ln of xy equals to e raised to x plus c. Because we know that e raised to the ln of an expression, e raised to the ln of an expression is just equal to that expression. So e raised to the ln of this one is just equal to this. So this is just xy equals to e raised to the power x plus c. So now we can divide this out by x and divide this out by x. So therefore we will have y to just be equal to e raised to x plus c all over x. So if we want to simplify further, we can say y equals e raised to x times e raised to c all over x. So we can further say that this e raised to c is just a constant c. So whether it is, whether it's kind of like 2c, 3c, 4c, or whatever constant, as long it is just a constant, you can represent any other letter to be that constant, or just any other variable. So there is just c, right? So we could say this whole thing is just d. We could say this is just c. So since it is c now, so we say c times this one is just c e raised to x all over x. So this now becomes our general solution of the given differential equation. So thanks so much for watching. Please do not forget to subscribe to our channel, like the videos, and please hit the notification button for updates on new uploads. Thank you. See you in our next lecture.